ওকে। আচ্ছা, বাইনারি ফাইলস ইন সি। তো বাইনারি ফাইলস প্রথমে কি সেটা আগে দেখে নিই, তারপরে গ্রাজুয়ালি মুভ অন টু ডিসঅ্যাডভান্টেজেস এন্ড অ্যাডভান্টেজেস। So binary files, unlike text files, are not human readable. They contain bytes and bytes of information, and therefore it generally translates into non-graphic characters. তাই জন্য যখনই কোনো আমি বাইনারি ফাইলস খুলবো, ওই বাইনারি ফাইলস এর মধ্যে আমরা সবসময় দেখবো কি ওর মধ্যে যে ক্যারেক্টার গুলো দেখাচ্ছে সেই ক্যারেক্টার গুলো আমরা জেনারেলি কিবোর্ড দিয়ে টাইপ করতে পারি না। আচ্ছা, binary files can store any kind of data, starting from the value of an int variable to a byte variable to a char variable, anything at all. Whereas text files can't do that. Text files can only contain characters, right? Now, disadvantages of text files নিয়ে আমরা শুরু করি, কারণ সেটা যদি আমরা না বুঝি তাহলে আমরা binary files কেন করছি সেটা বুঝতে পারবো। Firstly, the text files are in human readable format. Because they're in human readable format, any layman can open them up in Notepad and easily modify it. And they should not be used for storing records. This will be prominent when I show you this live example. তো আগের দিনের ক্লাসের আমরা যে প্রোগ্রামটা লিখেছিলাম যেখানে আমরা টেক্সট ফাইলসের মধ্যে স্টুডেন্ট রেকর্ড স্টোর করতাম সেই প্রোগ্রামটা এখানে আমি খুলেছি। এটাকে একটু ফুল স্ক্রিন করে নেওয়া হবে। আচ্ছা, সো এই প্রোগ্রামটাকে আমরা চালিয়ে আমরা একটা ফাইল ক্রিয়েট করি, ফাইলের মধ্যে দুটো রেকর্ড হবে। Let's run this. আমি ওই ফাইলের নাম দিয়ে দিচ্ছি start.txt. Let's see, it has no records. Let's insert a record. ধরে নে 70, 80 and 90 স্কোর করেছে। Let's see the record. আচ্ছা, তো যেহেতু ভালো স্কোর করেছে, his average is 80 and therefore his grade is 8. Now insert another record in which the student has failed all of his subjects. He has got 35 in all and therefore he has failed his subject. Okay? Let's exit from here. তো যে ফাইলটা আমরা তৈরি করলাম start.txt, সেই ফাইলটাকে একবার নোটপ্যাডে খোলা যায়। This is the start.txt that has got created in Turbo C3 bin folder. Let's open it. এখানে আমরা কি দেখছি? This is the record of the first student and this is the record of the second student. Now this student has failed all of his subjects. Let's do something. Let's modify these records. Okay. So আমি এই 35 টাকে so that his marks don't look too suspicious, আমি 35 টাকে passing marks করে দিচ্ছি। So I'm making it 40. So let's change all of these to 40. Remember, এই তিনটে হচ্ছে subjected marks, subject 1, subject 2 and subject 3, followed by this is the average. Now average should also be 40. Therefore he has passed and his grade should be E. Now let's save this file and close it. Now the next time I open the same file in our my program, it would show the modified records. The name of my record file was start.txt and the records, see, the records of the second student have been changed. Now the program does not know whether this record was entered by the user or whether it was added later by someone else by using the Notepad program, right? Therefore, this is a drawback. This is a very big drawback of text files. All right. This is why we must never keep records in a text file, because it's in a human readable format and anyone with a little knowledge that it can be opened with Notepad can modify those files. Moreover, they need to be parsed by the programs to correctly read them. Now, what do I mean by this? আমরা যদি নিজের প্রোগ্রামে দেখি, এখানে যে ফাংশনটা আমাদের ফাইলগুলোকে পড়ছে সেই ফাংশনটা হচ্ছে ডিসপ্লে student, not display student, display records. So এখানে একটা জিনিস দেখ, this is the line which is responsible for reading one record at a time. তো এখানে আমাদেরকে খুব স্পেসিফিক্যালি মেনশন করতে হচ্ছে কি what should be the format in which the data has been written. So it has an integer followed by another integer. Well, there are 5 integers followed by a character. এখন এই ফরম্যাটটা যদি আমাদের জানা না থাকে তাহলে পরে reading from the file would be difficult. Moreover, if someone happens to edit the file and change the formatting of the text, then we might run into a problem. Therefore, text files need to be parsed. They need to be understood before specific attributes from that can be read. And that is a very big problem. Karon, if someone happens to modify this file, then it would be problematic for us. And this parsing takes time. If I want to have a student structure that would have more fields in it, then there's no easy way of writing that file to a text file. আমাকে সবসময় এখানে এই ফরম্যাট স্ট্রিং এ এসে বারবার এই ফরম্যাট স্ট্রিংটাকে আমাকে বাড়াতে হবে। তো দিস ওয়াজ মাই ফরম্যাট স্ট্রিং, যেখানে এসে বারবার আমাকে ফরম্যাট স্ট্রিংটাকে বড় করতে থাকে। And that's not really scalable. Therefore, we more often than not never use text files for storing data. Now, then what are the advantages of binary files? Binary files, as you know, are not present in human readable format. They are present in computer readable format. Therefore, it cannot be directly understood by humans, and therefore it does not facilitate easy modification like text files. তো এর একটা এক্সাম্পল দেখানোর জন্য আমি যে প্রোগ্রামটা লিখবো এর পরে সেই প্রোগ্রামটাকে জাস্ট একবার চালাচ্ছি। সেই প্রোগ্রামটাকে চালিয়ে তারপর আমি তোকে এই এক্সাম্পলটা দেখাচ্ছি। কোনো কারণে এটা কাজ করছে না, তো লেট মি জাস্ট ক্লোজ দিস এন্ড রান ইট ব্যাক अगेन। ওকে, স্টার্ট Turbo C++। Alright. So stud bin is the file that we are going to write next. Let's just see it up and running. তারপরে আমি ওটার dissection করব। So let's see if there are any existing records. There are no existing records. Let's insert a record. Name of the roll number of my student is 1. The age is, let's say, perhaps 19, and the class is 13. College. And the name is Nilanshu. I'll display the record. Here are my records. Pretty fine. Let's quit this program and quickly check what the contents of that bin file is. Okay, so this is the file that has been created. Let's open it up with Notepad++. You see, the only readable thing that we have in our binary file is the name. Apart from that, everything is non-human readable. Now, if I were to add marks to it, even that would be human readable. Therefore, most laymen would be strayed from not changing this file because they don't know really the format of this. Therefore, this kind of files are best suited for storing records. Such that it does not affect our program output later, I'm going to delete these two files. Okay. All right. Then what next? The next advantage of binary files is that any kind of data can be easily written to and read from a binary file. The thing that I was talking about earlier about text files is that they need to be parsed when they need to be read by a program. So while parsing, we were mentioning the format string. The format string tells the program that a record would have this kind of data. But such kind of parsing is not required here. We can directly write a set of bytes into a binary file and read those set of bytes directly into a variable. That's what we're going to see next. So, binary files make it a lot easier for us to write and read a file. Now, what are the file modes for a binary file? Like in text files, here too we have 6 file modes for a binary file. So this might be very familiar to you that for reading a text file, the mode was write R, and for writing to a text file, the mode was W, and for appending to a text file, the file mode was A. Now, for binary files, these more or less remains the same, just with the addition of B. So read binary, write binary, and append binary. That's the only change that we have in the file mode for a binary file. Moreover, we have other file modes which can be used for opening a file in read and write mode. Therefore, for opening a file in read and write mode, the file mode would be RB+. For opening a file in read and write mode, but having properties same as write mode, it would be WB plus, and for append, it would be AB plus. Same as append mode, but it allows read and write. Moving on. So these are the 6 modes, file modes in which we can open a binary file. Next, binary file handling functions. There are 2 functions that we use for reading and writing to a binary file. For writing to a binary file, we use the method fwrite. This is the method that we use. The general syntax is the address of the data, the size of the data, the number of data we want to write to the file, and lastly, the file pointer. The same general syntax is followed in fread as well, which we use to read from a file. Now, the address data contains the address of the data that we want to write to a file. The size of the data denotes the size of one element that we want to write to the file. Number data denotes how many elements we want to write to a file, and lastly, this is my file pointer. Right? Now, the difference between size data and number data would be much clearer following the next example that I'm about to show you. Number data denotes the number of data items that we want to write in the disk. Now, think in terms of an array. An array may contain 5 elements. Now, size data would mean the size of one of that element. Now, that would be size ARR 0 of any one element. Now, number data would be, if you want to write an array to a file, then the number data would be the number of elements present in that array. Now, as our example goes, that the array was containing 5 elements, therefore, number data in that case would be 5. Okay? It would be much clearer following this example. Let's say we want to write the content of a variable to a file. Now, how should we go about doing that? First, we need to open our file in write binary mode. All right. Therefore, the method, the file mode is WB. Now, keep this in mind that every binary file would end or have an extension of .bin or .dat. So, in our example, the name of my binary file is dummy.bin. So this is the number that we want to write to the file. For writing to the file, we use the fwrite method. Now the fwrite method follows this syntax: address data, size data, number data, and file pointer. All right. So we want to write the content of this variable to the file. Therefore, the first argument should be the address of this data, of this variable. Therefore, we have written &num. Next, the size of the data that we want to write to a file. And the size of num is this. This is how we obtain the size of this variable. We alternatively could have also written size of int. It would have meant the same thing. Next, we have 1. This indicates that we have only one data item to be written to the file. Here we have just one variable. Therefore, this parameter is 1. And lastly, we have the file pointer. This is the example code with which we can write the content of one variable to a file. Right? And lastly, don't forget to close your file. Otherwise, the written variable would not be flushed to the file. Next, reading a variable from the written variable from the file. Similarly, we open the file that we earlier wrote to in this way. And the file mode is RB, which stands for read binary. Next, after reading the bytes from the file, we want to store in the variable num. Therefore, in the fread function, we send the address where the data must be stored after reading. Therefore, we have written here &num. Next, the size of the data that we are trying to read. Here, we have written size of num because we are trying to read an integer data from the file. Instead of this, we might have also written size of int. 1, because we are reading one data item from the file, right? And lastly, it's FP, or file pointer. Next, if we had printed the value of num, we would have got 14. I guess that's the value that we wrote earlier. Yes. All right. So next, let us come to how to write an array to a file. Now, following these 2 examples, you might think that, well, if I have to write an array to a file, I must run a loop and write each element of the file, each element of the array to the file. But that's not required because of how fwrite works. Consider this array which we want to write to the file. It is of size 5 and it contains elements from 1 to 5. Now, for writing this entire array to our file, we need not run a loop and write in each element individually. Rather, what we could do is we could call the fwrite function with ARR, with the array. Now, keep this in mind that ARR holds the base address of the array, address of the first element of the array. Therefore, we need not write ampersand in front of ARR because ARR itself represents an address. Therefore, we are simply writing the name of the array here, followed by size of one data element. This is an integer array. Because this is an integer array, we are passing the size of one element would be the size of int. Therefore, we are passing size of int here. Rather than doing that, we might use size of ARR 0. It would mean the same thing, right? Then, how many data items do you want to write to the file? The array contains 5 elements. Therefore, the number of data items must be 5, followed by the file pointer. Now, this, what it would do is it would write all of these elements to the file name dummy.bin. Now, it has to be opened in write binary. That's what we saw earlier. Then, lastly, we must close this. Now, let us see how to read this array from the file. Now, for reading an array from the file must be opened in read mode. Well, there's an error here. The file must be opened in read mode. All right. So after opening the file in read mode, in read binary mode to be more specific, we have to declare an array where we want to store the content of the file. Right? Now, about the size of this array. Because we have earlier written 5 elements in my binary file, it does not necessarily mean that the size of the array must be 5. It can be 5 or it can be more than 5. Right? The size of the array can be larger than the array being read from the file. That's what we can do. But the size of the array can't be lesser than the amount of data that we are reading from the file, or it would result in erroneous situations. Next, we must call the fread function. I don't know, I guess I copied it wrong. This should be fread. Okay. Now next we call the fread function and pass in the array where we want to store the read elements. Again, I know I seem like a broken record, but this you must get this right. ARR denotes the base address of the array. Therefore, ARR itself is an address, itself holds an address. Therefore, there's no need of writing ampersand in front of this. If I write ampersand in front of this, it would be wrong. ARR itself is an address, and therefore we pass in ARR as it is. Next, the size of each element that we want to read, that's size of int, 2 bytes for a 16-bit compiler. Next, we want to read 5 elements. Therefore, this is 5 followed by FP. It stands for file pointer. Next, we close the file. Now, if we want to print out the elements of ARR, we would have gotten 1, 2, 3, 4, and 5. All right. Now, using this knowledge, let us try to solve this program. So this program would cover all the different aspects of handling binary files. Now, what does this program state? We must write a program in C which would store student records in a binary file. Each student should contain the following fields: roll number, age, standard, or class, and name. Now, these are the following operations that we must implement in our program. We must handle creation of records, displaying all the records in a file, updating a specific record, deleting a specific record, and searching if a record exists or if it does not exist. Now, it's pretty evident that when these parameters are given to us, or these members are given to us which represent one student, it's beneficial to create a structure for it, right? Therefore, what we do is we create a structure for a student which contains the following fields: roll, age, standard, and name. Oh, all right, I forgot one thing. It is that it's not that we can only write integer, double, we can only write integer variables to our file. The variable can be anything. It can be of any type. It can be character, it can be double, it can be short, it can be float, it can be long, it can be any variable that is present that can be defined in C language. The thing is, what happens, because we are using a binary file, bytes are written to the file, right? And these bytes does not have any demarcation to it, that whatever is written to the file is of integer type, or whatever is written to the file is of character type. Whenever we call the fwrite function to write something to the file, then what happens is the byte representation of num is written directly to the file. Now, at the time of reading it, we read bytes from the file, but how does the program understand that whatever we are reading is of int type? That happens because we are storing these bytes in an int variable. Therefore, whenever we use the int variable, those bytes are interpreted as int type. All right, that's one explanation that I forgot about this example. Moreover, the variable type can be anything. It can be a character, it can be a string or a character array. It can be anything that we can write to a file, right? There's no restriction that only integer variables and integer arrays can be written to a file. All right. Okay. Moving on to our program. So I was talking about, because a student has a wide variety of fields, namely 4 fields, therefore it's better to create a structure for the student such that one student's records are in one single variable. That would be easier for us to work with. Therefore, our structure definition would go as follows. Because we have 4 fields, roll number, age, class, and name, roll number, age, and class are of int type, right? There's no confusion about it. It has to be of int type. Now, for the name, which is of type string, we have a character array, which is of size 1024. That's the maximum length of the name that we are taking. It could be shorter than this, but this is the maximum character that we have. All right, and this is the name of our new data type, student. Next, even though it is not mentioned in the question that we must make any more methods other than this, I still want to add 2 methods to our program. One method for taking input in a structure variable, and one method for displaying the value of a structure variable. Just one. It does not display the value of entire file. Just displays the value of a single structure variable, and it takes input in a single structure variable. Now, how do we do that? For taking input, we have written a function called input. It takes in the address of a structure and it takes the input directly in that structure using the indirection operator. This is the operator that we use when we want to access the fields of a structure through a pointer, right? So this is how the input method goes. Ampersand s dash roll means that whatever structure's address this pointer has, access the roll number field of it and provide the roll number field's address and store the entered roll number into that structure's field. Right? I hope it's clear. You have done it before. I don't think there's much confusion regarding this. Nextly, lastly, we take the name of the student as input. We call flush in this line because in the previous lines we have taken integer input. Now, as we know, by taking integer input, the enter key that the user presses after each input is not deleted from the input buffer. Therefore, what we need to do is we need to clear the input buffer and then go about taking string inputs, right? That's the explanation why flush has been used here. Next, we have a function which displays the content of a single structure variable. Therefore, what we do, we take the address of a structure variable here and we just display every field of that structure using a printer. Now, why have I used these -5f thing here such that I can display the records of a student in a tabular form, right? There's no other reason why I have used this. This is just to make our output look pretty. That's it. Okay. Now, creating a record and saving it in a file. Before we move on to the program, here's how the program would be written. First, for creating a record, the file needs to be opened in append mode. Now, why append mode? The file could be easily opened in write mode. Okay? But why append mode? We open the file in append mode because I don't want the previous entries to be deleted or overwritten each time this function is called. Meaning, suppose in the very beginning, the user stores one record in his file. Let's say this is my file, and the user stored the record of a student who has the roll number 1, right? The very first time. Now, if the file was opened in write mode, then the second time when this function would be called to store the second record of another student, what would happen is the file would be erased, and in place of 1, another record 2 would be written. Now this is a problem because I don't want the previous entries or the previous records to be deleted upon entering subsequent records. That is the reason why we are opening the file in append mode. Now, for writing to a file, as we know, the function fwrite has to be used. Okay. Now let's look at the code. So what we do is we take in the name of the file where we write those records and the address of the structure that we want to write to the file. Firstly, we open the file in append mode as discussed before. Then we write to the file. The syntax is quite similar. We call fwrite followed by the address of the structure that we want to write. Notice that we do not write ampersand s. Rather, we straight away write s. Why? Because here we are accepting the address of the structure itself. S contains the address of the structure because s is a pointer of the structure. Therefore, there's no need of writing ampersand in front of s because s contains the address of the structure that we want to write, followed by the size of the data that we want to write. That's size of student. Moreover, 1 because we are writing only one structure to the file, and then lastly fp, the file pointer. Yeah. Okay, and then we close the file. Pretty simple. Next, how should we go about displaying all the records present in it? Okay, so before we do that, let's discuss the algorithm involved while writing the method. Firstly, the file has to be opened in read mode, or more specifically read binary mode, because we are not modifying the records in the file. Rather, we are just spitting out the records on the monitor. Right? Then we read a single structure from the file using fread. Then we call the display function with the ret structure. Display function, as we know, displays the members of a single structure variable, right? Now, we continue reading a structure and calling the display method on that structure until we have read all records. Now, how do we tell that we have read all records? That's one question that needs to be answered, right? Let's take an example. To make matters simple, what I have done is I have, in this example, I have assumed that we write 3 records to the file, and each record is of size 2 bytes, right? But in our case, the student structure is not of size 2 bytes, rather it's of size, I guess, 1030 bytes perhaps. But still, just to make matters simple, I have assumed that each record is of size 2 bytes, and the file contains 3 records present in it from before. Right? Now, the objective is to compute the size of the file. Right? Now, what is the size of the file? The size of the file is in bytes is 6, because you see the first record is of size 2 bytes, the second record is of size 2 bytes, and the third record is of size 2 bytes. Adding these 3 up, we get 6. Right? The size of the file is 6 bytes. Now, how do we find out the size of the file? Sorry. To do that, what we do is we move our file pointer to the very end. We do that by calling fseek function on the file pointer. Then we call the ftell method to get the size of the file in bytes. And because our file pointer is at this location, therefore what happens is ftell returns 6. And that's conveniently the size of the file, the size of a file in bytes. Right? Now, how should we tell that we have read all the records in a file? Well, we do that by comparing the value of ftell and size. All right. So in the very beginning, our file pointer, let's use some different color here. For example, from the very beginning, the file pointer would be here, right? FP. Now, because our file pointer is here, what ftell would return is 0. Now, as we know, the size of a file is 6 bytes. Therefore, this condition is true. All right. Why? Because 0 is less than size. It's better if I illustrate this here. 0 is less than 6, hence the output is true. Then we go on to read this record. Now, after reading this record, the file pointer would shift here. Okay. This will be our file pointer. Now, at this stage, ftell fp would return 2. Now, 2 is also less than 6. Therefore, we are within the limit of the file that we are about to read. Therefore, we must continue to read this file. Next, after reading this record, the file pointer would move ahead by 2 bytes, and then the file pointer would come here. Okay. Now, for this, ftell fp would return 4, and 4 is less than 6. Therefore, we must go on to read this file. Right? Now, after reading the 2 bytes, finally, fp would come here. After fp comes here, ftell fp would return 6. Now, from the condition, it is evident that 6 is not less than 6. Hence, the condition is false. Therefore, we stop reading the file any further. Therefore, this condition is very important in determining whether we have read all records or not. I hope the explanation was quite clear. Okay. Let's see the use of this in our program. So in display records, we need not accept any structure. We just accept the name of the file whose records we want to display. So these are a few variables that we must take from before. Long size stores the size of a file in bytes. Now, why long? Because ftell, the return type of ftell is long. Therefore, the data type of size is long. The student temp is the structure variable where we temporarily store the record that was read from the file, just read from the file. Okay. Now, as we have discussed before, the file must be opened in read mode, and that's what is done here, RB, right? Now, to calculate the size of the file, what we must do? We must move to the end of the file. And this is done by calling fseek and passing in the argument fp0 and seek end. We must seek to the end of the file. Then we call ftell on fp. What this does is it returns the size of the file in bytes. Now, if you want to start reading our file from the very first record, we must now shift our cursor or the file pointer to the beginning of the file, and that is done through the rewind method. Okay. Now, I want to display the file in tabular format, which is exactly the reason why I have printed in this format. It's not necessary to display the records in this way, but this makes it look cleaner. That is why I have done it. Okay. So this line prints the headers of our table. Next, the condition that we saw earlier, this checks whether the file pointer is within the limit of the file, within the last record of the file, right? Now, if this condition is true, it means that we have not exceeded the end of the file, and thus it reads a structure from the file. After reading the structure, what it does is it displays, by calling the display function, it displays the content of the read structure. Okay. This sketch is not important. This sketch, I wrote it when I was debugging the program. This is not important. Alright. And this goes on until we reach the end of the file, which is determined by this condition. And finally, we close the file. Right? I hope this explanation was understood. Okay. Now, how should we go about updating a record in a file? Now, for updating a record in a file, the file must be opened in read and write mode. Now, why read and write mode? Because we do not know the exact position where our record would exist from beforehand. Therefore, we read the records present in the file one after the other by using fread. Now, if the currently read record matches with the record that we want to update, we stop and we move the file pointer to the beginning of the record that needs to be updated. And then we write the updated record on top of it. And that what gets the updation done in our file. Okay. Now let's see an example to understand this quickly. So in the very beginning, our file pointer would be here, right? And just like before, we assume that each record is of 2 bytes and each record contains a field which stores the roll number of the students. Now, the objective of this example is to update the student with the roll number 47 and change it to 53. Now, how should we go about doing that? Now, to do that, what we do is we read the first record. Now, after reading the first record, the file pointer would move here, right? FP. At the very beginning, the file pointer was at byte 0. And after reading the first record, the file pointer has moved to byte location 2. Now, after we have read the first file, we can check what the roll number stored in this file was. Well, it's 23 and it's not 47. Therefore, this record should not be updated. Now, because we have not found a record to update, we move our file pointer ahead to read the next record. Now, after reading the second record, the file pointer would shift here and ftl would return 4. Okay. So the current record that has been read contains the roll number 47 and we want to update the student with the roll number 47. So what we do is we move the file pointer back by how much? By 2 bytes. Now why 2 bytes? Because each record contains 2 bytes, right? Now how do we find out the size of a record? Now the size of a record in our case would be size of student, right? And in this case, the size of student is 2, all right? So this gives me the size of a single record. Size of single record. Now, we can move back from the current position. We can move back from the current position by going 2 bytes to the left, right? And that can be done by calling fc fp minus size of student and then c current with respect to the current position. This can be easily done by calling the function with the following parameters. But what I have seen during writing our program is that this does not work with Turbo C++. But what works is that if we mention the size or if we mention the byte position with respect to the first position or the beginning of the file, then it works correctly. Therefore, we're going to use that workaround. I don't know why this doesn't work. I haven't figured out why this doesn't work. I even searched in Stack Overflow, but still, this workaround, we need to work with this workaround, right? Now, when we have read this record, the file pointer would be at byte location 4, right? Now, from the very beginning, the byte location that we must move to update this record is 2. Now, how should we go to that particular record? If we must subtract the current position of file, if we subtract 2 from the current position of file pointer, then we can move the file pointer here, right? Therefore, what we are actually doing is we are subtracting current location of the file pointer with the size of one record, size of student. And this movement or this byte location is with respect to the beginning of the file. And that can either be mentioned by passing 0 or by writing seek set in this location. All right. I hope this explanation is clear. And this works with respect to the beginning of the file. You see, 4 minus 2, the size of student, gives me 2. And this is the byte location that we want to move to update this record. So after moving the file pointer here, we can rewrite or overwrite this record with the updated record, and the record would currently change to 53. Okay. Let's move on to the function. In the update record function, we take in the name of the file where the records are stored, the roll number of the student that we want to update, and the updated details of the student in this structure. This can be done in a more complex way by asking the user what he wants to update, how he wants to search the student. But for simplicity's sake, what I have done is I've taken the roll number of the student that the user wants to update, assuming that each roll number would be unique, and I've made the user to rewrite the record of the student again with the modified records. And then we are overwriting that record with the past student variable. All right. So for this, the file must be opened in read and write mode. That's done by calling the RB plus, by passing in the RB plus file mode. Then we calculate the size of the file by moving to the end of the file, calling ftell to get the size of the file. Then we rewind, we call rewind on FP such that the file pointer moves to the beginning of the file. And then we check to see if there are any more records in the file or not. We read a record, and then we check if the read record's role matches with the role of the student that we want to update. If it does, then we seek to the beginning of that record that we want to update, and that is done by calling fseek and moving to this byte position with reference to the beginning of the file. Okay, and then we override that record by calling fwrite, and S is the updated student record. All right, and then we break out of the loop because there's no need of searching the file any further, and then we close the file. All right. Now, I think you might be confused with why I'm passing S. Well, consider this. The user enters the roll number of the student that he wants to update. Now, what I do is I make the user rewrite all the details of the student. For example, if the student has the roll number 5, the age 15, the class 10, and name, let's say, Oyon, then and I want to change his age. This is his role. That's his age. That's his class. And that's his name. Now, if the user wants to change the age of the student, what the user would do? The user would firstly pass in the roll number, and then the user would rewrite all these fields. For example, the user would then again enter the roll number of the student is 5. What new record that he wants to update this record by? He wants to change the age. Therefore, in place of age, he would pass in 16. He wants the class to remain the same and the name to remain the same. Therefore, the user would rewrite or re-enter all of these records again with change in just age. And this structure would be written to the file. This would be more clearer when I run the program to check all the methods. But for the time being, just take it for granted and let's move on. Okay. Now, how should we go about deleting a record from the file? Now, to delete a record from the file, first the file must be opened in read, right? And then we must store all the records in the file except the record that you want to read, right? Where should we store the records present in the file? We must do that we must store that in an array. Now, for storing a record in an array, we must know the size of the array first. So how do we calculate the size of the array where the records of the file are going to be temporarily stored? See this. If I go to the end of the file, if my file pointer moves to the end of the file and we uh, call ftel on this file pointer, I'm going to get 6. And this is the size of the file in bytes. But how should we go about calculating how many records are present in the file? Well, that can be done pretty easily. We know that the size of each student or the size of each record here is 2. And the number of records, it's 3. Now, how should we get 3 from these two values? Easy, 6 by 2. Therefore, that comes out to be size by size of student. This formula gives us the number of records which are present in the file. Now, the size of the array should not be this. Rather, it should be the number of records present in the file minus 1, because we are going to delete one record from the file. Let's say we are going to delete this record. So how we are going to go about doing this? First, we will read the first record. We know that we are not going to delete this record. Therefore, we're going to store this record in the array. Next, when we read the second record, we know we are going to delete this record, and this is known through the roll number. We're going to check if the roll number matches with the current record, and we're going to skip that record. As we want to delete this record, we're not going to store this in our array, and we're going to move ahead. This is the record that we don't want to delete. Therefore, we're going to store this record in our array. Therefore, the array would contain just 2 records, the first one and the second one. Right? Next, what we're going to do, so this is our array. Next, we will write the records present in the array to this file itself. But I want the contents of this to be emptied first. And this can be done by reopening the file or close the file and then opening the file in write mode. As we know, when we open the file in write mode, the old contents of the file are flushed or are deleted, and then new contents are written from the very beginning of the file, right? Okay, and then we write the content of the array to the file using F. Let's see how the delete record method will do. First, we require the size of the file. Right? The size of the file can be easily calculated by going to the end, calling ftel. You've been seeing that for the previous methods. Now, the total records in our file would be size divided by size of student. The size of the file in bytes divided by size of one record. Now, the array in which we are going to store it should be of an array of student type. Right? And this has to be created dynamically because we never know in advance how many records are going to be present in our file. Therefore, we need to create this array dynamically, which is why I have declared a pointer here. Okay. Now, the size of this array should be total records minus 1 because we are deleting one record. All right. Now, this condition tells me if I have reached the end of the file or not. Okay. This is quite similar to updation. Right? But here, instead of updating, what we're doing is we're skipping that record, which we want to delete. Now, if the roll number of the student that we want to delete does not match with the current record, then we store it in the array. And this is done by keeping an index variable here. And this index variable increments itself every time one of the record is pushed into our array or stored in our array. So we check if the record that we want to delete is not the current record, and this is done by checking the roll number. Okay. So if the current record is not equal to the record that we want to delete, we store it in our array, and we keep incrementing our index variable. Whenever the current record has a roll number of the student that we want to delete, this condition evaluates to false, and that record does not get stored in our array. After doing this, after reading all the records from the file, we close the file and reopen the file in write mode. Now, doing this flushes the contents of the file and new contents are written from the very beginning. Now we know from the previous examples that how we write an array to a file. So to write an array to a file, we simply give the name of the array as the first argument, the size of one element of the array, followed by how many items are there in the array, and that's equal to total records minus 1. This is our file point, and we close the file. And lastly, we must free this array because this array was dynamically allocated. That is done through the free method. Okay. Lastly, we have a method for searching a record in a file. Now, for searching a record in a file, we open the file in read mode, and just like display, we read each record in a file, and we check to see if the roll number of that record matches with the record that we want to search. If it matches, then we have successfully found our record, and then we display the record exists. If no such record has been found, then we simply print the record does not exist. Right? So our method works as follows. We take in the name of the file in which we store our record and the roll number of the student that we want to search. We store the size of the file in bytes in this variable, and this is a variable which holds 0 if the record does not exist, and it holds 1 if the record exists. Now we traverse through the entire file to check if that record exists or not. If that record does exist, then we make the value of found as 1 and we break out of this loop because there's no need of searching it any further. It's quite like a linear search, but just instead of an array, we do it on a file. Now, if the value of found is 1, then the record exists, else the record does not exist. We do close the file here, of course. Okay. Now, finally, the main method. In the main method, we ask the user the name of the database file. That is done through these two statements. These are the many options that we show the user that we follow. These are the operations that can be done on this file. If the user presses 1, he or she can insert a student record. For 2, he can display all the records. For 3, he can update an existing record. For 4, he can delete an existing record. 5, to search for a record. And finally, 6, to quit. Then we ask for his choice. We do this repeatedly because I don't know how many times the user is going to enter an record. Right? Unless and until the user presses 6, we continue to display these menu items over and over again. In our switch statement, if the value of choice is 1, we input the record that the user wants to write to the file, and then we call the write record with the name of the file followed by the record he wants to insert in the file. If the value of choice is 2, then the user wants to display the records. Therefore, we call the display records function and pass in the file name. Don't forget the break after each case. Okay? In case 3, if the user if the value of choice is 3, the user wants to update a record. But to do that, what we do is we input the roll number of the student that the user wants to update. Then I want the user to rewrite the records of the student that he wants to update. And that is done by calling the input method. What the user would in this case do is the user would keep those the values of those attributes of the student same that he does not want changed, but he would update or change the value of that member that he wants updated. For example, if the user wants the age field to be updated, then in place of age, he would put in a different number, whereas for the other attributes, the user would put in the same value as before. Then we call the update record with the name of the file, the roll number of the student to be updated, and the newly updated record. And this method updates that record in the database file. Next, if the value of choice is 4, then the user wants to delete a record from the. To do that, what we do is we input the roll number of the student that the user wants to delete and call the delete record function, to which we pass the name of the file and the roll number of the student that the user wants to delete. Okay. Lastly, if the value of choice is 5, Then the user wants to search if a record exists in our file. To do that, we input the roll number of the student to be searched and we call the search records function. Finally, for case 6, user presses the value 6 if he wants to quit from our program. What was the use of putting case 6 as a different case in our switch state? We have done that such that upon pressing 6, the default case does not get executed. If we would have not written case 6 in our switch statement, then what would happen is when the user presses the value 6, then invalid choice would be displayed, and then finally the program would quit. But we don't want to do that because 6 is a valid option. Therefore, this case was important. Lastly, if the user presses anything other than 126, then the default case would get executed and the program would display invalid choice. So this process or this process of displaying the menu items, taking an input would run only if the choice was not 6. Anything other than 6, if the user enters, the program assumes that the user wants to reuse our program again, right? And finally, we return 0 to come out of menu. All right. I know that was too long. Okay. Let's just finish it off quickly and close this video once and for all. Okay. So let's run our program and see how our program works. Okay. So the name of a file, let's call that stud.bin. So let us insert a record in our database, in our file. So roll number is 1, the age is 19, the class is 13, is in college, the name is Nilanshu. Let's display the records. See, one record is there in the file. Now, let's insert another record. Let's give the roll as 2, the age as 21, the class again as 13, and the name as Nilanshu. The records present in the file are Nilanshu and Ramu. Now let us say the age and the class of Nilanshu has increased. Therefore, we want to update that record. So let's give the option as 3, and the roll number of the student is 1 that we want to. Now here we need to rewrite our records. Like I want the roll number to be same. Therefore, the roll number of the new record should also be 1. I want the age to be updated to 20. Therefore, the age field must be 20. I want the class to be updated to 14. Therefore, the class should be 14. The name is same. Therefore, write Nilanshu. This could have been done in a better way, but that would have meant complex code or a bigger code. This program is big as it is. Therefore, I didn't want to increase any more of its complexity. Therefore, I went with this design choice. Okay. Let's see if the record has been updated or not. Let's see. Age of Nilanshu is now 20 and the class is now 14. Let's say I want to delete an existing record. So I press 4. The roll number I want to delete, let's say roll 2. Let's check the records in our file. It's 1, 20, 40, and Nilanshu. My record has been deleted. The record of Ranjoy has been deleted. Let's add a few more records. Let's say roll number 2, it's something, plus something, another. Oh, mistake there. No worries. Okay, same as before. All right. Let's say I want to search for a student having the roll number 3. So I press the option 5. I want to search as 3, and the record does exist. Let's search for a roll number that does not exist in our file. Let's say you with a roll number 5. No, there's no student in a record in our database that has the roll number 5. So 5, the record is not. Lastly, quit out of it. Okay. All right. So that's the end of our program. But there's one thing that I want to discuss after this. So what are the drawbacks of storing files in this fashion. Yeah, I know. The text file had a drawback. Said there was some advantages of binary files over text files. That is why binary files were used. Now I'm telling binary files have some drawbacks too. Well, yes, there are always two sides to a coin. And therefore, we must discuss its drawbacks too, along with the advantages which was discussed before. This way of storing records in a file is the traditional method. This was done way back when we didn't have computers of such power. Like this was done when the processors such as 8086 and Pentium was in rise, right? So the traditional method of storing records in a file is the way that we discussed in our program. But this has several disadvantages. What are those? The first is the ad hoc or purpose-built data. The database that we have created for ourselves can only store student records which have 4 fields: roll number, age, class, and name. Right? If I want to store anything else, for example, if I want to store the marks of a student, I need to create another database from scratch. And I need to rewrite all the functions for that. Therefore, whenever we require a database for another application, we must go and rewrite our program. And that's the problem. There are so many databases that we use nowadays. We have Facebook, we have YouTube, they have databases for God knows how many things. Google has a database for indexing the pages of the web. It has a database for supporting the videos that are uploaded to YouTube and whatnot. Therefore, for creating a separate program for each database application is time consuming, and moreover, it is difficult to maintain them. Right? Now, moving on to the second drawback. Each operation needs to be separately implemented by writing new methods. For example, if I were to ask you to display the records of the student in the descending order of their age, then for that I need to modify the display method or write a separate method altogether. Right? Next, if I want to display uh, students, those students who all belong to class 10, even for that, we need to make a new method. Thus, for every new operation, I must create a new method. Okay? This is problematic. Why? Suppose you are running a company which makes inventory management systems. All right. So you created an inventory management system taking of the user in mind that these are the options that the user might use. You created the product, you sold the product to the customer, and then the customer, after using it for a certain amount of time, he calls you up and he tells you, I want this function to be implemented. Then what you would do? You would go on to your program, add a new method, compile to make a new program, and deliver that to him. And it might happen that that program might have some bugs introduced to it, which is why the functions that were working before are not working now. And there will be many divisions of your program. And that also means a maintenance nightmare. And it's obviously a difficult job. Each new operation requires a new method, meaning every time you want to do something different, you must change your program. You must go on to change your program, write something new, and then you can work on it. All right? Now, thirdly, changing the data model. Now, what do I mean by data model? By data model, I mean a student record here consists of 4 fields: role, age, class, and name. What if I want to include the, let's say, marks of the student? So for doing that, firstly, I would require to change the structure definition. Followed by structure definition, I would require to change the write method, uh, the display method, the display method, the update method, and uh, and the search method. right? So changing of a data model requires rewriting all the existing methods that we have. Okay, and that is again a problem. How many times are you going to change your program? The data model would change frequently. It might change frequently. And that does not mean you're going to keep on writing programs for them over and over again, right? And lastly, it does not implement transactions, data integrity, and security. Now, what do I mean by transactions? For example, let's say you are trying to insert a recording of it. Now, after writing the first two fields, the roll number and the age, the power goes out. Now, when the power goes out, the file is in an invalid state because the necessary items have not been written to it and the file has not been closed properly. Right? Because it was an incomplete write operation, because writing a record means writing all the four fields. The next time that you open the file, you might not be able to read the file properly. It might not understand the end of file properly. Right? And moreover, because the student record was partially written, that must be discarded. And that is not implemented by your program. It's too difficult to implement. Right? Therefore, it does not include transaction. Transaction means a unit of work which has to be done as a whole, but it should not be done at all. Writing the records must be done by writing all the four fields, not just two, not just one, not just three, but all the four. So this does not implement transactions. Moving on to data integrity. Suppose we allow roll numbers that can be present, that a student can have is from 1 to 50. If the user enters 70, our program would conveniently write the record in our file. Okay? So data integrity is not checked by our program. This can be checked by implementing if statements at the time of taking input. But still, there are some other kinds of integrity which would not be checked here, such as if we have two databases, one for storing the students, one for storing the marks, we must always insert the marks of the student that exists in the student database. If we have two separate databases, those are called, what should I say? I guess hierarchical integrity, right? So data integrity is not checked in our program. Moving on to security. Though the binary files are obfuscated and cannot be read directly by a notepad by a layman, but still there are security researchers out there who can take your binary file and read each byte specifically to understand if this byte is an int or if this byte is short or this byte is double. And then you can quickly figure out the process in which the file was made by understanding the structure of the file, right? And moreover, anyone is free to change that file or delete that file. Therefore, security is not implemented in the traditional way of storing the records, storing the files. Therefore, what has happened is nowadays no one uses these kind of programs to store records in a database. What they do is they use DBMS or database management systems to input records. And the DBMS implements transactions, data integrity, and security. Also, it supports changing of data model without affecting the previous data. Now, all of these are implemented in data management system, right? But this paved your way, paved the path for the next semester, where database management systems will be taught to you. Okay? The popular data management systems are Oracle DB, MySQL, PostgreSQL, etc. Right? This was how traditionally the files, the records were kept. And in the next semester, you're going to be taught how today database management systems are used to store files in a very proper and a very efficient manner. All right. So that's about it. I know it was a long video. But still, we have classes of 2 hours. We have classes of sessions of 2 hours. This was barely 2 hours, I believe. So I hope you've understood the process in which I explained this. I wrote the program. And if you have any doubts, feel free to call me and solve your doubts. All right? Okay. See you again later. Bye for now.